use geometry to find the value of the definite integral from -3 to 3 of the square root of 9 minus x squared dx. So in order to solve this problem, we have to be familiar with the equation of a circle. And we'll just discuss circles centered at the origin. So if we have a circle with center at 0, 0 and radius r, then the equation of the circle is x squared plus y squared equals r squared. And then if we solve for y, we get y squared equals r squared minus x squared, and therefore y is plus or minus the square root of r squared minus x squared, where r is a number, it's the radius. And that's what we have here. We have the positive square root. Now the positive square root gives us the upper semicircle. That would be y equals the positive square root of r squared minus x squared. And the negative square root would give us the bottom half, the lower semicircle. We have an upper semicircle, and if this is r squared, then the radius of our circle is the square root of 9, which is 3. So r is the square root of 9, which is 3. So let's make a sketch of our upper semicircle, centered at the origin, radius 3. So it's going to go over here and like that. And this number is going to be negative r, negative radius, negative 3. And this number over here is going to be the radius, 3. This is 0, and the radius is 3. The equation of this semicircle is y equals the square root of 9 minus x squared. So this integral represents the area of this semicircle. So the area of a semicircle is 1/2 of the area of the whole circle. And the formula for the area of the circle is pi r squared. And so our radius is 3. So we get 1/2 times pi times 3 squared. In other words, we get 9 pi over 2. So that's the area of this region, and therefore that is the value of this definite integral.